Today we're solving the Leetcode number 101 problem, symmetric tree. Given the root of a binary tree, check whether it is a mirror of itself, i.e. the symmetric around its center. So starting from the first node, 1, and then going to the left and going to the right. So in this level, both twos are equal. And going further down, this 3 equals to 3, 4 equals to 4. So this is returns to true as the output. And today we're gonna look at the iterative way of solving this problem. This problem can be solved with also recursive approach. If you're interested, you can check out my other video. But for the iterative way, we're gonna build a data structure. In this case, we're gonna use the queue, which means we're gonna put the node inside of the queue. Let's start from the root 1. And because you wanted to evaluate the left and right all the time, so we put 1 starting from the 1, and then second one would also be 1 because you want to have left and right, even though like in the root there's only 1, but once it gets to the second one, so it's, and then we pop this out if they're equal. Of course, it's just the root. And then the second one would be the left one, we put 2 in there, and the right also 2. So this is also equal. So then we pop this one out, this 2 actually, one by one. And then here, if you look a little bit closer, you can see the 3 is actually the left of this left node, and the 3 on the right is the right node of the right of this one. So we want to make sure these 2 are equal. So we append this 2 into our queue. Similar thing is 1 and 2. So we put 3 in there. And then because they're equal, so we pop them out. And a similar thing with 4, just with this on the right side, so it's gonna be the right side of the left node, and this one is gonna be the left side of this right one. It's gonna become clear once we get to the code, so let's dive inside of the code. So we start from constructing the tree. So we need a class called tree node, and inside of here we're gonna construct the value which defaults to 0, and left defaults to none, right also none. And then just to initialize the value equals to the value in the left, also the right. And then comes to our solution class. We need a function, let's call it is Symmetric. And we pass in our root in here as the argument, and we need a queue. Oops, it should be squared bracket for an array. First we need the base case. If the root equals to none, then we just return, because it's not valid to continue comparing. But other than that, if it's not none, then we want to append this root inside of the queue, like I illustrated before. We start from the 1, so we append 1 here for the left, even though it doesn't make any difference in the root, but it will be for the rest of the left and right. So let's append this, and we want first declare our left and right both to be tree node, or we can declare this on the top. So inside of this continuing loop, we need the while loop. As long as there's elements inside the queue, then we just keep going with the loop until it runs out of nodes. So we need to get the left and right. So left would be the one you pop. You can use this 2 as an example. So the left would be this 2 and the right would be this 2. So if we append the left first, then we pop out this one and then put it as the first one in the queue. Remember, the queue goes first in, first out. So the first element in the array, and then we pop out. Once it's been popped out, then the first one will become the right node, and then we also pop this one out. And we already have our left and right, so we need to evaluate if left of value does not equal to right the value, then we'll return false. If other cases would be, we keep going, not just the left and right, we wanted the left of the left, like this 3, and also the right of the right, this 3, to compare this 2, and also this 2, the right of the left and left of the right. So if left the left and right the right, so if they both exist, then we want to do the same thing as the beginning. We want to append it inside of the queue. Append left to left, and then queue to append right to right. Else if, what if when there's only one of them, or this means there's a left but there's not a right, so this should be false. Similar thing with right. So let me just start from left. So left to right and right left. q.append. So this part would be the middle one, the for left.right and right.left, 4 and 4. So we need to append left.right and also append right.left. Else if left.right or right.left, only one branch exists, return false. But other than that, we need to end the loop and return true if all of these things criteria are met, then we return true. So let's call this function first an instance of the class solution, and we build the tree node. We can just use these 3 nodes, 1 and then 2 and 2. So the first one, second one, the third one. Start from the third one. Tree node 2, none. To the left is none. To the right is also none. And then the second value, the value on the left. So its value is 2, but we don't really have to put none because the defaults are none. So, and then here's our root value 1. So for 1, the value is 1, but it has a left node and a right side node. So just put it in there. And our result is gonna be from this instance, call the function is symmetric and pass in the root value and just print this result out. Let's see if this one works. So q dropped the y. Okay, typo line 33. You probably already caught that one. Run it again. Okay, another one. Print true. Okay, let's change the value to 3. So it's gonna be 1, 2, and 3, and see if it's gonna return false as expected. It's because it's not symmetric. Yep, there you go. So this is our iterative way of solving this problem, and I hope you enjoyed it and I hope it's helpful. Thanks for watching and see you in another one.